This is Matthew Poes with Poes Acoustics, and in this video, Towmky, Towmky, said, "Happy Thanksgiving!" I know, we're past Thanksgiving. Takes me a while to answer questions. A few follow-up questions, please. What problems are inherent to passive radiators? In the GSG behind, okay, actually, these are all different questions. So, what problems are inherent in passive radiators? So, passive radiators are, for those who don't know, another form of like Helmholtz resonator type box, if you will. It is like a bass reflex box, but it's using a mass differently. So a ported subwoofer has a tube with a mass of air in it. And that mass of air resonates at a specific frequency because the mass of air changes depending on how big that tube is, right? Because it's how much volume of air is in there. You can replace the mass of air with something else. You can replace it with a disc of the same mass, and it will do basically the same thing. However, there's a compliance factor that air doesn't have because the air isn't attached to the tube in any way. So the air can move in and out of that tube back and forth like that completely freely. So there is no compliance to speak of. But a passive radiator does have a compliance factor. And typically, most of them are not very good. So there is a way to design passive radiators that are better, that would be extremely low compliance or high compliance. I'd be saying that backwards. But most of them are not designed that way. So most of them are way too stiff. And as a result, it overdamps the movement. So you get a resonant frequency because of that, and you get some worse performance. The other thing is, just like a woofer cone moving in and out makes noise, so does a passive radiator. So just like a port tube can make noise, so can a passive radiator. And so those would be the inherent problems. They're an imperfect device. And one of the issues you often run into is that in order to get the amount of movement that you need about twice the displacement in the passive radiator as you have in the subwoofer, which is usually achieved by simply using two of them. So if you have an 18-inch woofer with 20 millimeters of X-Max, you do two passive radiators. I mean, even if that passive radiator had like 30 millimeters of X-Max, you're going to need two. And you're better off having more displacement than you need, because what happens is as it moves towards its extremes, it makes more and more noises. And if you are way off, it'll destroy itself, and that can certainly happen. So those are the issues with passive radiators. They're a great device, and they have their purpose, but as I mentioned before, if I was to design my perfect subwoofers, they'd be sealed, and what I have in my room is sealed. Okay, now in the GSG behind the screen BTS 21-inch subwoofer designs, the port can be aimed to the side to avoid rippling the screen. Is there an audible reduction in port noise because the port is aimed away from the listener? I would say the answer is yes to that. You know, if it's just aimed to the side, you're still pretty on axis to the noise it's making, but port noise is typically higher in frequency, so when you aim it away from you, it does reduce the level. I find it to be most inaudible when it's aimed at the floor or the ceiling, I suppose, or the front wall behind the screen instead. All of that seems to work better, but yeah, I mean, moving it to the side probably is reducing the noise a little bit too. If a ported sub is tuned at 16 Hertz and I roll it off above that, like 19 Hertz, is that an effective way of reducing the port issues below audible levels? I mean, you're killing the benefit of the port in a lot of ways, because what you're doing is preventing the subwoofer from operating loudly in the range at which the port is of maximum efficiency. So I don't know that I would do that. I understand where you're going with this, but you're better off just fixing the port in the first place with a better designed port. Or don't have a port. I mean, the ports make noise. They're going to make noise. There's not a lot you can do about it. You can design them and optimize them all you want. There's a lot of companies that put a lot of effort into highly optimizing those. The real solution isn't to throw in like a high-pass filter. It's to redesign the port to be quieter. So one of the best ways when you have slot ports to do that, the typical flaring you see is like a roundover. That's not a flare, and it doesn't actually do anything useful. What you really need to see, if you look at the research papers on port tubes, you'll see that this is what they found too, is that it needs to be, so imagine a slot shape still, but it's still coming in quite a bit with a flare. And so the sides can be straight, that's okay. A little bit of flaring would be good, but sides can be straight, not the end of the world. You can still have this high aspect ratio design of a slot port, but instead of having, if the port height is supposed to be 3 inches, then at the end you want it to be like 6 inches or even 8 inches. At the middle of the port, You're going to reduce it down to that, let's say 3 inches. And then you're going to expand back out. So the port's going to go from bigger to smaller and bigger again, just like a round flared port would do. And that will help reduce the port noises quite a bit. The round over on the edge has a little tiny bit of benefit, but it's mostly looks when people do that. So the other thing you can do is damp ports, but I've played with that. It's a very minor effect. I had thought that that might be like a way to fix it, but it really doesn't. I think I've told this story before. I mean, a lot of people like to argue with me as if I've like never done this before. I was a DIYer before I got into all of this. It was just like you guys. It was the best way to get the most bang for the buck. And I designed a lot of subwoofers for myself and for others for that matter back in the late 90s through the mid 2000s or so, using all the same software that we all still use today in many cases. I mean, new stuff came out over the years, but I was using whatever was the best software you could get at the time to design these subwoofers, and I played around with all sorts of ideas. And along the way, I met Dr. Earl Geddes, who knows quite a bit about this. I also met some folks from JBL, who some of them actually have moved on and founded their own companies or done their own things, but a lot of them had been involved in a port paper specifically that they wrote where they investigated ports and they figured out some optimization techniques. So I talked to them because that was really insightful too. Because I, just like everybody else, wanted the most bass per square foot that I could possibly get for the least amount of money. And drivers are very expensive. So when you're trying to do this on a budget, the idea of taking a driver that costs $300 or $400 or more, I mean, some of the best like 18 and 21 inch drivers can be $1,000. So the idea of taking that and having to double that cost versus just making a port that has relatively little cost because of the wood materials just didn't make it. So I wanted to do like a ported design that worked well. And I wanted it tuned really low, so I tuned them at 25 hertz, then I tuned them at 20 hertz, then 18 hertz, then 15 hertz. I even tried a 10 hertz one once. And what I kept finding was that I could solve one problem, but I created another. In fact, I helped design a subwoofer as recently as about 4 years ago, made by a manufacturer that used a port tuned very low, and the port resonance, because the port, in order to, the subwoofer had like almost 40 millimeters of X-Max, the driver. Because the driver had so much X-Max, the port area had to be very large. Now the tuning was actually, I say it was low. It wasn't 10 hertz or anything like that. I think it was 16 or 17 hertz, something like that was the final tuning frequency. But still low, it's below 20 hertz, right? And we've got this 40 millimeter X-Max driver. It's getting like 4,000 watts RMS of power to drive it. And the problem we ran into was that the port was so large that the port resonance was below 100 hertz. And so it honked. Now, by putting a low-pass filter of around 50 hertz on it, we fixed it. And because it was tuned so low, I kind of use it as like a 50 hertz and below infrasonic sub in the system. So I made it usable, and it's okay. But the original intent and what would have led to better performance in the room was to run it up to 80 hertz. And my hope was that we wouldn't have heard that port resonance. But this isn't like the first time I'd ever run into that. Like I kind of knew it was going to be a problem. It's just that the company that was making it only wanted to do, they didn't want to do sealed subs. They only wanted to do ported subs. So it had to be ported. This was the compromise solution we came up with, and in my opinion, it didn't work out. I mean, if you guys heard this thing, it is a beast of a subwoofer. It is extremely high output. It plays crazy loud. Its CTA 2010 numbers are absurd, but I don't think it's a good sounding subwoofer. It also has very high group delay because of the way it was designed. And I think it's audible, but the bigger issue actually is that port resonance. So the reason why I got so anti-port, like I said, was my experience with ports. Like I've just had the same experience over and over again. Now you might look at what I'm saying and say, well, yeah, but if you took a sealed subwoofer and you stuck like that same driver in a sealed box, it would be exceeding X-Max and making ugly noises too. And yes, but the port resonance was a problem at almost any SPL level, way, way below its peak. You know, it wasn't like it just came up when it got loud. So the port resonance was always an issue. With the smaller ports, the port chuffing comes on well below the limits of the system. So port chuffing ends up becoming its limit. So that's another issue. And so with the sealed subwoofer, that issue that you have of the max SPL is addressable with more subs. And then you don't get those ugly noises and they don't come on earlier. And it's easier for me to create protections like you're trying to do that prevent the noises from forming in the first place. Just checking if there was more on the back. There is not. So that's my answer to that one. It is my personal preference. I will say this. In the design world I work in, I don't know anybody that uses ported subs. So all the other top guys I work with, or people who I would consider like my contemporaries, they use sealed subwoofers across the board in theaters. So while I understand that on the forums and everything, ported subwoofers are very, very popular, amongst professional integrators, I only see them on lower end systems. On higher end systems, I only see sealed subwoofers. And the other people I talk to who are part of these groups, when I ask them about their opinions or why do you use sealed subs, it's the same thing. They just don't like ports. Ports tend to cause more problems than they solve. And in those high-end systems, we typically have the budget and freedom to just add more drivers to resolve the problems that the sealed subwoofers have. So I don't think I'm wrong. What can I say? Thanks for watching my videos. I appreciate all these questions, and keep them coming. Keep asking questions. Please like my videos if you like them at least. If you don't like them, please like them anyway. Please subscribe to my channel. I need more subscribers. The count was going really strong for a while, and it's kind of leveled off, and it's starting to come back now that I've gotten better at putting videos out. We're going to have some more videos out. I'm going to probably make a different video on this, actually. But I'm going to try to do more content. I've been telling you guys this for a while. I've got some ideas. They're hard to do, so we've just put it off, but we're getting more and more serious about making a plan for how to do it. I just have a lot going on in my life, so it's hard to like take these things and seriously make them happen. But I promise you, when I talk about things, they typically happen. It just might take a year or two. All right, well, thanks for watching my videos. I got more stuff coming.